In the last video, we learned that the binomial probability formulas are embedded into our calculators, which means that we can find any specific probability we are interested in, as long as it's for the binomial experiment. Now, this is great because it means that we can get out of doing a lot of the by hand work using the multiplication rules and the addition rules and the complement rules that we needed for chapter 5. A lot of the work, but not all of the work. So this is wonderful, but we can go one step further and we can use that embedded calculator function to find the probabilities for a table that we talked about in chapters 5 and 6. So I could find the probabilities over here without having to make a tree diagram and do all sorts of multiplication rules and all that, just by using the binomial functions embedded in my calculator. So let me prove it to you. So we have a random family that has 4 children. We're going to find the probability distribution for the random variable x equals the number of boys for the family if we assume there are only 2 equally likely biological sexes. And I'm going to give you a hint. Don't put anything into your calculator, any x value, into your calculator. So you'll notice that this is a binomial experiment. For example, it's independent. There's a fixed number of trials, namely that they have 4 children. The probability of success is 0.5 because of the equally likely part right here. So since it's equally likely, we know it's 0.5. Since n is equal to 4, we know that our fixed number of trials is 4. We know that the biological sex of children is independent as far as can be determined. So we know that is the case, and we know that the probability of success is consistent. And we only have 2 fixed outcomes. So this is totally a binomial experiment. It satisfies all 4 of the criteria. So that means that we can use binom PDF to find all the values for the probabilities over here. So these are going to be the probabilities that x equals a number, right? So x equals a specific number. And the way we write that is x is equal to little x value, right? So that the number of boys is equal to 0, 1, 2, 3. And you could say a. I mean, it really doesn't matter. N or pound sign. It doesn't matter what you put there. All right, and then I have this little hint about not putting an x value in the calculator. So let me show you how that works. Let me clear this out. So if I go to the distribution menu and I go to binom PDF, because I'm interested in specific x values, right here, binom PDF, and I tell it that I have 4 trials, because there's 4 children. The probability of success, the 2 biological sexes, is 50-50, and I'm going to leave the x value blank. I'm not going to put anything in, and I'm going to paste. And then I go here and I press enter and I paste. It actually finds all the probabilities. And you can see there's a little right arrow over here on the right, which means if I hit the right arrow, it'll scroll over and let me see more probabilities. So I can find all my probabilities, 0.0625, 0.25, and so on. It's a little confusing to look at like this in horizontal form, especially if there's a lot of decimal places. So what I might recommend is that you store, that's hitting the store button here. It says, I'm going to take that last answer of yours, and I'm going to store it. I'm going to tell it to store it in L1. So I'm going to hit second, actually L2, second 2, enter. Fine, doesn't look like anything. But now when I go back to stat edit, because L2 of course is in stat edit, look at what I've got. It shows me those probabilities right there in a column. And I can type by hand the x values. So 0, 1, 2, 3, and 4. And I can see the table beautifully. That store feature is a really nice feature. So there we go. I have all the probabilities. So 0.0625, 0.25, 0.375, and so on. And just for fun, let me also show you one more thing. Oops, let me fix that pagination 1 second. There, I'm going to add another little column over here just so you can see something real quick. What would it be like if I used CDF instead of PDF? So let me show you with the calculator. So I'm going to quit and get out of here. I'm going to go back to my distribution menu. Binom CDF is letter B. There it is. And I'm going to say there's 4 trials. The probability of success is 0.5. I'm going to leave x value blank. I'm going to paste. And I know that I want to store this in L3 right now. So I'm actually going to hit store L3. You don't have to store if you don't want to. You could just press enter. But I'm going to store it because I want to see it in that column. So if you know you want it to be stored, you can press store, which is over near the 1 button, and tell it what column. I'm going to tell it L3 and press enter. So I want you to be able to see this and see the columns and see how different they are. So the one on the middle, that's the probability that x is equal to specific values. So x equals 3, x equals 4. That's the probability. Over here is the binomial CDF, and you can see it starts out the same. But the next number over, 0.3125, that's equal to 0.25 plus 0.0625. There's a little bit of rounding there with that 1 at the end, so don't worry about that. 0.6875 is 0.375 plus 0.25 plus 0.0625. That's what binomial CDF does. It finds the probabilities that x is less than or equal to those values. So let me type those in. And of course it should make 1 by the end because this whole middle column should add up to 0. And you can tell the difference, I have it right there, it's a less than or equal to that number. It's not just equal to, it's less than or equal to, so it's going to add up. It starts at 0.0625 and it accumulates, that's what C stands for. So it's just a little refresher on what that means. And we can see it in table form, and we don't have to find any of it by hand. The calculator just kind of does it all for us because the calculator knows the formulas. Now let's use that same technique to answer our free throw question from earlier. So the average free throw percentage for an NBA player is 77%. i.e. the chances they will shoot a successful free throw. You're going to randomly select 3 random NBA players and have each of them shoot a free throw. Let x be the number of successful free throws. Well, we already know this is binomial and all that good stuff. So let me just show you real quick. If I wanted to find that middle probability right there, I would just take binomial PDF. Let me get out of here, quit. So binomial PDF, which is letter A. I have 3 trials, so I have 3 players. The probability of success is 0.77. Sorry, I'm having problems with my computer. 0.77, and I'm interested in 2. Or I could just leave it blank and press paste, and it'll find all of them for me. There's 0, there's 1, there's 2, 0.4091, and there's 3, 0.4565. So I left some of them in there. There's the third one right there. There we have it. Now notice for this next part, they want us to compute the probability that less than 2 players, well that's key, less than 2. So let me highlight that, blue I think. So less than 2 players make their shots. There, I sort of got that color coded. Okay, so less than 2 would be these two added up. So you could just add them, 0.0122 plus 0.1222. But of course, less than 2 is also a binomial CDF. So you could just use binomial CDF. So let me grab that letter, binomial CDF with 3 trials because N is still 3 players, fixed number of trials. Probability of success, these are still National Basketball Association players, so 0.77. And then I want it to stop at 1. Paste, enter. And right there, I had 0.1344. Right. So let's continue on using this binomial PDF and binomial CDF for the next example. It says the student takes a multiple choice test that has 20 questions. Each question has 5 choices, only one of which is correct. And the student randomly guesses at each answer. We've already seen this before. We proved a few pages ago that this setup is binomial. You have a fixed number of trials, which is 20. You have the probability of success, which is 1/5, and all that good stuff. So they want us to describe in words what we're looking for. Well, it'll be that the probability of a student getting 4 correct answers out of 20. So P of 4 equals the probability the student guesses correctly on 4 answers. On 4 answers out of 20. Right? And then we can calculate its value because this is a specific one. It's giving us a number. So if you look at the table, that's talking about binomial PDF right here. When it's a given number like 4, then it wants the probability of 4 that's binomial PDF. So that's what we're going to use to be able to calculate this. Okay, so I typed this up. Just keep in mind the words portion is a big deal. You want to be able to write it out in words what they're talking about. And don't forget about the 20. A lot of students forget about the 20, but that's not appropriate because you can't just say they get 4 correct. 4 correct out of 2, 4 correct out of 4, 4 correct out of 20. By the way, 4 correct out of 2 would be incorrect. That's impossible. So I found this with my calculator using Binomial PDF. So let me go grab it. Binomial PDF, which is letter A. And then I would tell it there's 20 trials because there's 20 questions. And then there's 1/5. You can either type 1/5 or you can type 0.2 as the decimal, either one. And I want 4 specifically. So I'm going to go paste. And there it is, 0.2182, which is what I said it was right there. All right, now to pass the test, the student must answer 70% or more correctly. But that's 70% of 20. So your first mission is to find what 70% of 20 is. How many correct is that? And then we can figure out the probability. All right, I start off with passing. Passing is 70% of 20. That's equal to 0.7 times 20 or more, right? So this is 0.7 times 20. That's what of means in mathematics. So if I go 0.7 times 20, 0.7 times 20, there we go, I get 14. So I know that I want to have a score of 14 or higher. So x is greater than or equal to 14. And I figured it out that way because, of course, we have a table that tells us what to do when x is greater than or equal to a value. We can look at rule number 5, the 1 minus binomial CDF, n, which is 20, p, which is 1/5, and x minus 1, so I want 14 minus 1, so I want 13. So I'm using that 5th rule, that 5th line right there. All right, so let me pull up a calculator here. So I want 1 minus binomial CDF, so that's letter B, which, by the way, you can just hit alpha B because I know it's letter B and get there, or you can go use the arrows and press enter, right? Always double check the top of your screen and make sure it's matching the one you want it to, which in my case it is because it's binomial CDF. Then my probability of success was 1/5, my number of trials was 20, and I'm going to stop it at 13 because I really want the probability of 14, 15, 16, 17 up through 20. So I'm going to stop it at 13. It'll add up all the probabilities up to 13, but then it'll take it away from 1. As a matter of fact, well, here, I'll do this first. And I get that number. Now remember, probabilities can never be higher than 1. So you want to look over to the far right where it has e negative 6. That means that it's times e to the negative 6, which means the decimal point is 6 spots over to the left. Let me show you what this would have looked like without the 1 minus real quick. So let me grab this and just show you what the answer was, because it's actually going to be 0.999 and some change. There it is, 0.99999. See those 5 nines and then the 8 and 1? That's why you have to move the decimal spot so far over for your result. And there we have it. So it's 1 minus 0.999982, which has 5 zeros and then a 1/8. And just a note, it's very, very unusual to pass this 20-question test by randomly guessing. This is far below 5%, right? So far below the 5% threshold for unusual, or even the 1% threshold for very unusual. This is very, very low. Okay? Which means you always want to study before an exam. You don't want to go in and randomly guess. Just my little lesson to you.